Hello, welcome. My name is Mr. C, and this is my first on-air live review for Human Geography of the year. Um, I am at my school, and so if there's a weird echo, it's because this room is probably not the most conducive. Also, I have a small fan over here blowing cool air on me, so if that gets too noisy, let me know in the comments, and I will fix that. This is my third year doing these online review sessions, and I kind of wanted to go over a couple of things. So we do use Google Hangouts on air as our format for these reviews. One of the things, for whatever reason, we've not been able to get the chat function to work very well. So behind me is a website where you'll find lots of resources and materials for human geography that I have created and I have put online. On there, you will find a link to post questions for tonight's review. If you have not done so already, that's perfectly fine. Continue to do so. Continue to post questions as we go. So that is kind of where we are going to go today. Right now, there aren't any questions. So here in a few minutes, what I will do is I will pull up some of the questions that were frequently asked last year, and I will address some of those topics again, and you can get your questions added as we go. Just a little bit about myself. I've been teaching for about 13 years. I've been teaching both world history and world geography. I am an AP reader. I've been to the AP reading 3 times. And the benefit of that is I now know a lot about how the test is graded, what the test committee is looking for, how the assessments work, how the rubrics work, how the norming process goes. And so whenever I talk about some of these topics, I'm able to give you some inside perspective. I will not be at the reading this year, but I plan to go hopefully in the future. But anyway, so that's a little bit about me. Anyway, I'm going to go ahead and just talk about some topics that come up. I'm basically going to talk about a new topic every week. Basically, a new unit for you. By now, you should be aware that Human Geography has 7 content units that they focus on, and we're going to kind of work through one of those topics each Thursday night at 8 o'clock. I will answer questions from whatever questions you have, regardless of whatever unit we're in. So if something comes up that that you're struggling with, go ahead and ask, and I'll answer that to the best of my ability. But for right now, because we don't have any questions, I'm going to go ahead and talk a little bit about some major ideas and concepts in the population and migration unit, because that's where I always start the course in terms of major stuff. I actually technically start with the traditions unit, but it's a very small portion of the test, and so I don't spend a lot of time on it in my reading session. So, all right. So we're going to talk a little bit about population and migration today. I'm going to use the whiteboard a little bit. That's why my face is a little off-center, because I want to be able to use the whiteboard some today. Because there's some important things to understand. Okay, so the population and migration unit really gets to a couple of questions. One is, where are people on the planet? Where do they live? Why do they live where they live? What factors drive those decisions or those patterns? What causes people to leave where they are and go other places? What are some motivating factors to that? How do governments and institutions respond to those types of movements and types of ideas? So those are some of the big concepts that we want to talk about. One thing that I think is very important to talk about to start off this particular unit, as well as others, it's really an important recurring concept in human geography, is the idea of place. And when we talk about place, basically what we're talking about is what makes a location unique from other locations on the earth. So what does it look like? What does it feel like? What does it smell like? What does it sound like? And in the course of human geography, what's important about that is that people build very strong connections to place. They feel very strong connections to where they live and to those unique factors and features of the location. And when they build that strong connection to place, that often dictates a lot about their behavior, especially when it comes to things like migration. So some people might ask, well, after a hurricane, why do some people move back to a place, or why do they not leave in the first place when there's danger or there's flooding or their house is destroyed? Why don't they just move someplace where there's no hurricanes? That's a good question. I've never lived in a place where there's hurricanes, so I've never really had to think about that on a personal level. However, the idea of place plays in there, in that this is something that's important to me and special to me and that I have a connection to. And so I don't want to leave this place necessarily because it is meaningful to me. And so when we talk about, especially about migration, we really want to understand what is so powerful and so significant and so important that overrides that idea of place, overrides those senses and powerful feelings and things that people have to make them leave. Because history tells us that most people, especially up until the late 20th century, didn't move around very much at all. So that idea of place was very important. Okay. All right. So keep that idea of place in common, both as we're talking about the idea of population and the idea of migration, because they're both important things. So basically, one of the really interesting things to look at is there's over 7 billion people on the planet Earth, and one of the interesting, most fascinating things about the planet Earth is, and especially where people are, is that where people are and settlement patterns are not evenly distributed. So, for example, we might look at something like, what is the population density of the Earth? And I don't have that number on the top of my head. But when we look at arithmetic density, right? So that's just a simple math problem. We have X number of square miles of planet Earth. We have X number of people. So our arithmetic density is going to tell us how many people per square mile. So just simple division tells us that. The problem with that, though, is that figure, that arithmetic density, assumes that population is evenly distributed. So really, but that's not the case that it is. So really, what we want to look at is how do we measure where people actually live and the density there. Okay, so as a general rule, people can't live where it's very hot. They can't live where it's very cold. They can't live where it's very dry. They can't live where it's very wet, and they can't live where it's at very high altitude. So if you take out hot places, cold places, dry places, wet places, and high places, you're actually quite limited, right? Because there are large parts of the planet to which those characteristics apply. So we're not going to have people living in the Arctic, not going to have people living in the deserts, not going to have people living on Mount Everest, things like that. So if we take all of those things together, then we start to limit where people actually do live and what that distribution looks like. In addition, people have to live where they can find the resources that they need to survive. So usually this means, where can they find access to fresh water? Where can they find access to reasonable farmland for agriculture? Because hunting and gathering and nomadic herding and those kinds of things are completely legitimate ways of life. They just don't support large populations, right? So you have to have reasonable farmland, you have to have access to fresh water in order to sustain large populations. So if we take out the high places, low places, dry places, wet places, and high places, and we take out places that don't have reliable access to good farmland and to fresh water, we're actually limited to a few areas on the planet that can sustain large scale agriculture, okay, or large scale population, excuse me. So what we end up seeing is clusterings of people in different places. And basically on the Earth right now, traditionally, coming into the 21st century, there were basically 5 large clusters on the Earth, okay? And of those 5 large clusters, you had one in South Asia. Okay, so along the Brahmaputra and the Ganges River basins in India, a very, very large population base has been sustaining this way of life for thousands of years. It has now become the largest population cluster in the world because of population growth, population policies, which we'll talk about here in a few minutes. Of course, East Asia has another one, especially in China, along the Jiang and the Huanghe River in China. So you're looking at over 1 billion people living in that cluster. Large cluster in Central Asia, Germany, France, Poland, some of those kind of Central Asian areas, basically around agricultural and mineral resources. You also have a very large cluster in North America, especially along the East Coast and the Bosnia-Wash region of the East Coast of the United States, from Boston through Washington, D.C. and into the South. Excuse me, there are some emerging areas of population clustering as well. Africa is beginning to emerge, especially areas like Nigeria and Ghana and Accra, some places like that in West Africa, are beginning to emerge because of their exceedingly high population growth rates. And we'll talk about those growth rates here in a few minutes. So those clusters are very important to know because that kind of compounds some of the problems that come with a growing population on planet Earth, because people have to live on the same places that they have to survive. So they physically exist where they grow their food. They physically exist where they have jobs. They physically live where they have to extract the resources to live on. And so this kind of compounds the problem in these incredibly dense populated areas of how do we provide enough resources to survive on. Okay, there are a couple of terms that I want to kind of toss out and help us to remember in understanding population. Okay, and they're basically these are things that you will hear a lot in reference to how population is measured. There's lots of different population measures, and I recommend that you go check out my video on HGAP 5. Hold on, I'm missing a 5 here. I'm sorry. Okay. Sorry, the number 5 should be on there. I apologize. I recommend that you go check out my video on the site and be able to see me kind of go into more detail about population measurement. But basically, there are a couple of things that you need to know. One is the idea of average life expectancy. So how long is somebody expected to live? It's a simple number that actually has a lot of complicated reasons for it. Okay, rate of natural increase, or RNI. And rate of natural increase basically it says how much does a population grow through natural means, not migration means, but through natural means over a particular course of time. We want to understand things like crude birth rates, or how many children are born in a place per 1,000 population. Same thing with crude death rates. We want to understand those kinds of how many people are dying at a particular place. Now, these are all very important statistics to keep in mind and understand how they interact with each other. Okay, total mortality rate, total fertility rate, those are some other population measures that you should probably be familiar with. Okay, another thing that I want to talk about just real briefly is, and actually I say briefly, it's not. This is kind of one of the main kind of concepts. One of the big questions that gets asked a lot of times in our reviews was when it comes to models and what kind of models do we need to understand, the theories we need to understand. So I'm going to talk a little bit about some models and theories today as they relate to population specifically, and a little bit about migration. So I'm going to go ahead and do that for a few minutes, and we'll come back and look at if there are any more questions that have popped up in the meantime. But basically, based on last year's questions, there were lots of questions about what's called the demographic transition model. And so we're going to talk a little bit more about the demographic transition model today and what that looks like. So the demographic transition model is an attempt to understand the relationship between the population growth of a place or a location or a region and its relative economic development. Okay, so as a country or place or location develops economically, what happens to its population in terms of growth? And this is important because it kind of helps us understand and plan or predict what might happen in the future if we understand some of the things that happened in the past. So some things that are that you need to know about the model before we look at it is it's based on the experience of the Industrial Revolution in Western Europe and the United States. So as Western Europe was going through the Industrial Revolution, lots of data was collected on all kinds of things, but particularly on birth rates, death rates, and things like that. Later, people came back and analyzed that data, and they began to see some patterns. And that's important to understand that this is based on a particular region and their particular experience. Okay? It's also based on the fact that these regions had relatively low populations at the beginning of this process, and not necessarily at the end of the processes. After we talk about it in some more detail, we will get to kind of what happens and why maybe this is a good model and maybe it's not. Okay, all right. So I'm going to do some stuff on the whiteboard. I am actually going to have to do everything backwards because I am broadcasting this like in a mirror format. So bear with me a little bit. Okay, all right. So I'm going to go to the whiteboard. I'm going to make sure you can see what I'm doing here. Okay. You really can't see that very well, can you? Oh, yeah, you can. If I get out of it, you can. Yeah, there we go. Okay, so in the demographic transition model, we start with, I'm just going to draw some lines on here, and then I will explain what these lines kind of are. All right, so this is a very, very, very crude drawing of the DT and what it looks like. So, and this is based on two things. It's based on CBR, or crude birth rates. It's also based on crude death rates. You know what, I have to do this backwards also. So, CBR and crude death rates. I'm actually getting pretty good at writing backwards. I don't know why, but I am. So anyway, so CBR versus CDR. And basically, here's what happens, is that over time, what happens with the crude birth rates and crude death rates is we're going to look at the pink, and actually let me do it this way. We're going to do CDR is actually our pink here. CDR. All right, so CDR is the pink, CBR is the blue. All right, so what happens over time with the demographic transition model is every society starts in a traditional phase. Every society starts with hunters and gatherers, or very, very small communities, very small civilizations, things like that. Very primitive, where you have high mortality rates, you have low life expectancy, you have a high infant mortality rate, which is the number of children or babies born before year one. So you have a lot of people being born that aren't living very long. Okay. You also have societies that have very high labor demands in terms of agriculture. So what ends up happening is these societies have to have lots of workers and lots of people in order to function. In order to do that, they have to produce lots of people. They have to have lots of children, very high total fertility rates. So if we look at our CBR, it's very high, all right? At the same time, because of disease, because of malnutrition, because of lack of resources and lack of wealth, and the environment in which they live, the CDR, or crude death rate, is also very high. So basically what happens is during this time, there is not a lot of population growth. And if we take the green markers, population growth is going to be this green line. And I'm going to put it there. Okay, does that look right? Hey, all right, I'm doing good backwards here. All right, so in stage one of our model, All right, this is stage 1. You have high crude birth rates, high crude death rates, and very low population growth. Because all the population is being used to sustain itself. You only have enough people to get by and survive. Okay? Then something happens, right? Something happens in a society over time. And what happens is kind of marked here in where I'm going to put this dotted line, which is stage 2. In stage 2, something happens, right? Actually, 2. I should do the numbers backwards. 2. All right. So in stage 2, what happens is the crude death rates drop, and they drop pretty dramatically. This is due to technology, advances in science, advances in medicine. People are living longer, and therefore the crude death rate drops. Higher life expectancies, lower mortality rates. Yay, everything's great. People are living longer, and that's always a good thing. More people living longer, better than fewer people dying earlier. This is a general rule. Okay, so this would appear to be a good thing. So this would appear to be, you know, happy fun time in whatever society we're living in here in stage 2. Okay, but notice something here. While the crude death rates are dropping because of science and technology and things like that, the crude birth rates are not. The crude birth rate stays high. So what we end up with is this gap right here. This gap right here between these two. And that gap, that space in between, represents a massive population increase or massive population boom. Because we have more people, fewer people dying, but the same high number of people being born. So our population is going to grow very, very, very rapidly. This is a problem because the more people we have, the more strain that's putting on our resources. The more food we have to have, the more water we have to have, the more jobs, the more infrastructure, the more homes. So this is actually a quite dangerous place for society to be here in stage 2. Now, is it as bad as stage 1? We could debate that. We could debate not living very long and having lots of, you know, infant mortality is just as bad. But we have this situation where we have this population explosion and this pressure on resources. Part of the reason why the CBR doesn't drop is because while the pink line, the crude birth rates, can be determined by science and technology and innovation, the crude birth rate, or choices about family planning, choices about how people are going to you know, construct and design and plan their families, are cultural decisions. And cultural decisions tend to take much longer to change than these scientific things often do. And so what we end up with is this situation where there's a lag between these two things. Okay, all right. So then that's stage 2. One of the worst places to be is in stage 2, and a lot of countries run into a problem where they bring in a lot of these technological advances, and science allows them to bring these birth rates down, but they don't address the social or cultural issues that lead to family planning choices and eventually cause this bulge. So at some point, there has to be either a government or social organization program or some kind of other pressure that convinces society to rethink and evaluate their norms about family size and things like that. When that happens, we see this dramatic decline in crude birth rates, okay? And we'll put this here, and this is number 3, or number 3, okay? So in stage 3, we have a decline in both of these things, okay? So crude birth rates are going down, crude death rates are going down, okay? And then eventually, put this here, we get to stage 4. Stage 4, they balance out, right? Now, they balance out very low. So stage 4 looks very much like stage 1, but the opposite, where everything's very low and our population growth line is very flat. Okay, so basically what we're seeing is science is changing and death rates are going down, culture is not changing, then culture changes and goes down, and eventually we get to some level where it flattens off low. Now, there is an economic progression that's occurring here. There's an industrialization that is occurring here. There is an advancement economically in terms of moving from primary to secondary to tertiary, quaternary type economic activities that's occurring here. Okay, as that happens, okay, the need for smaller families takes over, and we begin to see these population changes. Okay, now some theorists talk about stage 5, and what stage 5 is when your death rate actually is higher than your birth rate, so that your society has adjusted to these birth rates to a point that they're actually your population begins to shrink because more people are dying than are being born because you have an aging population and incredibly low birth rates. So this is the kind of thing that we see in Japan, the kind of thing we see in Western Europe, things like that. This is also the kind of thing we would see in the United States a little more frequently, except we are very open in our society when it comes to immigration. Immigrants often help us to offset some of these things, especially immigrants from developing countries that still have some of these cultural norms about family size actually allow us to help us offset what would be very low birth rates in our own country. And one of the things that I also want you to look at here is the green line. You'll notice that we start off with very low population growth, and it grows very quickly as we get into stage 2 and 3, and then it begins to level off when we get to, this actually should be sharper than this, a more steep increase, because this needs to be flat when we get to 4, so it kind of levels off right there. Okay, now, once again, low growth on the ends, high growth in the middle, and we actually might see when we get to stage 5 a little bit of a downturn in this. All right. Okay. Now, one of the things that's important about this is the reason why this continues to go up, even as our rates are dropping, is something called population momentum. And basically, what it means is it's the law of large numbers. If you're multiplying large numbers or exponentially growing large numbers, then your total number is going to get exponentially large or exponentially big as you go along, right? And so it's not until we get to the top of this where that momentum begins to slow down, right? And so that's kind of how the CBR works. Now, as we said, this can be problematic at times. And part of the reason why it's problematic is, one, it's based on that experience of Western Europe. So can we say, all right, if we follow this model, then we are going to progress? Well, maybe not, because you know, and when we talk about economic development in a few weeks, we'll talk about structural versus liberalist models. So do these places, do these countries, do these societies have the power and ability to control all of these factors? Do they have the power and ability to control the economic development that's occurring at the same time? What happens if you get into stage 2 and you're not able to curb family size and those values and mores? What happens if you are not able to do that and you get stuck in stage 2 and the population increase and you have an increasing pressure on your resources, okay? So it's also important to remember that this was not a predictive model. This was not a planned model. This is, we're going back and looking at data that had happened in the past, and we're uncovering this pattern. It's a legitimate pattern. It's a legitimate thing that happened during the Industrial Revolution in the West, but is it necessarily an appropriate thing to use for planning purposes? Well, if we plan right, we can get into these different stages and these types of things can happen. And I'm a little less optimistic about that idea. Okay. It also assumes that everyone's growth experience, economic experience, that everyone and every country and every place kind of goes through the same process and has the same things. And you know, Western Europe and even North America during the Industrial Revolution were pretty homogenous in terms of their values, in terms of their ideas, in terms of how they went through this, of how they went through these stages, where other parts of the world vary quite a bit from that. And so, is there necessarily a connection? So, you know, when we talk about this stage here to drop this population, there are natural ways to do that. But there's also what frequently ends up happening is the government will come in and it will put what we call anti-natalist policies in place, or policies to discourage having multiple children or any more than two, in order to force the population to decline, to take pressure off resources, and to kind of begin to move a society in this direction. Some of those policies are helpful in terms of, you know, encouraging family planning and empowerment of women and things like that are always part of those successful plans, or the ethically good plans. But then there's also more harsh plans that are not as ethically strong. Things like the one-child policy in China, which was effective in lowering population, but it also had some very nasty side effects that were kind of a byproduct of an authoritarian government, right? So it can be forced and it can be encouraged in many different ways, and the government can step in and take on some of those policies as well. Okay, all right. So that's kind of the DTM. There have been several FRQs on the DTM over the course of those. If you go to HGAP5.com, you can go in and you can see all of the released FRQs are there. They're all there for you to look at, to practice, to see the rubrics, to see how they were scored and things like that. So all those are available to you on that site. It's free, by the way, so you don't have to pay anything for that. Okay, so that is kind of the DTM, and I'm going to write that up here. DTM. Yeah. Okay. All right. I'll give you 1 second if you want to. Once again, I'm having to write backwards. I keep forgetting how to write backwards. All right, DTM. There's a horrible glare right here, and I apologize for that. Okay. Let me see if we have any questions that have been posed. Okay, not yet. All right. So since there haven't been any questions posed yet, let me go on to another topic that is frequently asked about. I'm going to erase our DTM, so hopefully you got that concept. Once again, this is a very common thing. It should be in all of your prep books. It should be in all of your textbooks. So it's a very common idea. So if you didn't get that image, just Google it, and you'll find all kinds of images of the DTM. So another question that was asked frequently last year was about a guy named Thomas Malthus. Thomas Malthus. I'm not going to try to write his name backwards because it's long and it's got letters in reverse, but trust me, Thomas Malthus. So, and there's kind of lots of discussion about Malthus and his ideas. So Malthus lived in the late 18th and early 19th century in Britain. And basically what he is known for is population theory and theorizing what happens to a society as it continues to grow. Okay, so I'm going to talk a little bit about Malthus's theory, and then we're going to talk about an alternative to that theory. Okay, so Malthus argues, okay, here's a person, okay, so you've got, you know, man and woman, husband and wife, however you want to define them, all right, they have, let's say that they have 2 kids, okay, so they have 2 kids, okay. Okay. Then these kids have 2 kids. I'm just going to be smiley faces now. They have 2 kids. And then these kids each have 2 kids. Okay. Anyway, and so on and so forth from generation to generation. What Malthus is arguing is that population is going to double every generation, okay, minimum. If we are at replacement rate, okay, and replacement rate in our society is 2.1. Okay, so 2.1 people is replacement rate. So Malthus's argument is that because of this, what ends up happening is that the population eventually grows at an exponential level, right? It grows not at a 1-to-1 ratio, but at a greater than 1-to-1 ratio, okay, because of this, okay? But here is our population growth. So Malthus argues the problem with this is that if we take land, if we take the earth does not grow. It doesn't get bigger. Our ability to put land into production for productive human purposes, such as food and such as housing, is very limited. We cannot put land into production to provide for people at a fast enough rate to keep up with an exponential population growth. Okay, so Malthus is going to argue that land and resources are going to grow arithmetically or linearly, right? So he's going to argue that if the blue line equals resources, okay, put an R here for resources, all right, and our black line equals population, okay, then at some point, at this point right here, our population exceeds our resources. We can no longer keep pace with the population. So what happens then? Society kind of falls into chaos, according to Malthus, right? Well, Malthus is going to argue that this will lead to war as people fight over resources. It will lead to famine as we run out of food. It will lead to all kinds of bad things. And that eventually what will happen is the population will decline. Population will decline. I'm going to redraw this a little bit. The population will decline to a point that it once again drops below that growth over time, right? So this is going to be, you know, wars, you know, famine, things like that, okay? War, famine, things like that are going to happen, okay? All through this area. Right, so that's Malthus. Malthus is basically saying we need to put population controls in place. If we don't, this is going to be the result, okay? This massive chaos and chaotic situation that occurs from this exponential growth that is so much faster than our ability to put resources to work, okay? All right, so that's Malthus. So we're talking about 19th century Thomas Malthus. However, for the most part, what Malthus's worst case scenario, the apocalypse, the end of the world, that he described, didn't really happen on the scale that he predicted. Now, part of that is exactly what he said needed to happen, which was, you know, some checks on population. However, there are other figures that an alternate perspective to Malthus. One of these is a woman named Esther Bosserup. And Esther Bosserup is lived in the 1950s and was a population theorist as well. And what Bosserup said is that, I'm going to use blue, use green for my population line, is that yes, population grows at an exponential rate. Okay? But what Bosserup says, though, is that land or resources or human beings' population to put resources to use doesn't necessarily always grow at the same constant rate. What she argues is that population pressure, the doom or the feeling of problems and consequences due to population growth, actually forces human beings to be innovative, forces people to work harder, to do new things, to find new ways to solve problems. right? If we can't put more out of it, right? So what she theorizes is that as the population and resources line get close together, that human beings figure out ways to be more productive, and the line jumps up. Okay, it'll go over a little bit, and then it'll jump up again. So basically, because of the population pressure, Bosserup's argument is that man is always able to stay one step ahead of the population. They're always able to stay one step ahead of what's coming down the line in terms of this catastrophic situation that Malthus predicted. So she's going to argue that Malthus's prediction never happened because of technology, because of human innovation, because of resources, because we are gradually advancing over time in order to keep up and produce things. So that also brings in this question of neo-Malthusians. The neo-Malthusians is exactly what it says, new people who believe in Malthus. So during this time, and even today, there are people that still think, well, maybe Malthus was not completely wrong. Is it reasonable to think that in a situation in which resources are scarce but population is not, is it reasonable to think that people will react in that way? I think it is reasonable to think that. But how does that actually work itself out? So Malthusians will look at places like China or India or sub-Saharan Africa, where the population growth rates are incredibly high, and the resource pools are not getting any bigger, and say there could be a problem here. Okay. Now we can go back though and take Esther Bosserup one step further, and we have this thing called the Green Revolution, and I'm actually going to write it in green. So G R E E N. How about that? I'm getting good at this. Put the Green Revolution up there, and you really can't read that on there because of the glare. Okay, the Green Revolution. And basically the Green Revolution is exactly this idea. We're going to use science to overcome the physical limitations of what the earth provides, right? So if we take a piece of land, it's only going to produce so much naturally. How do we get it to produce more? Okay, well, we put more into the land in terms of fertilizers. We put more in the land in terms of water. We go into science labs and we genetically create higher yielding strains of rice or wheat or corn in order for people to be able to survive on the same amount of land, right? If we can get more out of land, they can produce more, then we are able then to feed more people with the same physical geographical space. And so this kind of revolution in science, this revolution in biology and agriculture kind of starts in the 1960s with a man named Norman Borlaug, who was experimenting with wheat. And he basically comes up by splicing different types of wheat together, comes up with a strain of wheat that allows for greater yield. So instead of getting, I'm making these numbers up, instead of getting 100 grains of wheat out of a stalk, maybe he's getting 200 or 300. So he's doubling or tripling the production. Or we're able to have things grow faster so that we can then grow multiple growing seasons or multiple harvests in a year that's able to get more out of that. All right. So if we start with Bosserup, we can take that idea one step further and talk about it in terms of what is science actually doing in the late 20th century in order to get us to that point where it is a reality. Okay. And writing that was kind of pointless because of the glare. You can't see it, but that's okay. All right. So those are some kind of important concepts to remember for population: the DTM, the Green Revolution, and its impact, Malthusian, neo-Malthusians, Bosserup, and the idea that technology can have a huge impact on the outcomes of agriculture and population. Okay, still no one has signed up today or are added questions today, and that's perfectly fine. So that's great. I do want to talk a little bit though about migration. So migration is an interesting concept, especially when we get back to that idea of place. So if historians argue that most people throughout the history of mankind most people never lived more than about 50 miles from their place of birth. So most people, most human beings whoever lived were relatively stationary, sedentary people, right? That did not move around very much. Now, historically, there are massive historical migrations, the Bantu migrations, the historical migrations from China, the historical migrations from India, things like the African slave trade. All these kinds of things are these massive historical migrations. But part of the reason why they're notable is because of their size and because migration historically is fairly rare. But basically what we need to understand is a couple of things. And the first thing I'm going to talk about is why people migrate. Why do people leave their place that is important to them, that has cultural significance, that has historical and familial connections? Why would we leave that? And so there has to be a pretty significant either pull from someplace else or push in that place. And usually these push and pull factors play a pretty crucial role in those processes, and they often work together. So it's hard to say this is a push factor and that's a pull factor, because usually those two ideas work together. But for example, most people who migrate for economic reasons. There is something economically either wrong with where they are or perceived better someplace else that encourages them to move to that new place. So economics is number one. Political is number two. There is something going on in the political situation. A new leader, a civil war, poor policies that make it hard to live, things like that. Environmental things are often another reason why people migrate. So hurricanes and environmental degradation and desertification in Africa. People are going to have to leave because they're now living in one of those dry places they can't support life. So those are some of the big reasons why people migrate. But are there any particular rules that kind of dictate these things? So that's when we want to talk about a guy named Ravenstein. So Ernst Ravenstein is talking about what are some rules that dictate migration, or why people move and why they don't. So, and basically Ravenstein has a group of laws. There's about 12 or 13 of them. But basically when I teach the class, we come back to the 5. There are 5 rules of migration. One is most people migrate a very short distance, not a long distance. So the idea of the transatlantic migration out of Ireland or out of Italy, in the 19th century, a very rare occurrence. Okay, the idea of massive movement of people from China over many centuries and even millennia is not a common occurrence. Most people who migrate a short distance, maybe just to the next village, maybe to a larger town nearby, maybe right across a nearby international border. Most people, for example, who are leaving Mexico don't go to Canada, they go to the US. Why? Because it's a short distance and there's no reason to go any further than that. Okay, so at the same time, we have a situation where